Okay, so next up we're looking at partial roots. This is kind of like, I don't know why, but I just find this one like really fun. Like I really like this thing. It's just kind of a cool little trick that you can do to help you sort of simplify things. So basically, here's what it says. So when you have a radical that you're taking, and the index number is a product of two things. So like 4 is 2 times 2, 6 is 2 times 3, 10 is 2 times 5, right? So your index is a product of two numbers. You can split it into two separate, like nested radicals, like a Russian nesting doll, where you take the roots of those two individual numbers and you can do it in either order. Okay, which I know doesn't make much sense, but let's look at an example. So, like this guy right here, this is a fourth root. So, 4 is 2 times 2. So, what you can do is you can split this into a square root of a square root of 81 because these two index numbers of 2, the invisible understood 2's, multiply still to the 4. And then the square root of 81 is 9, so then this is the same as the square root of 9, and the square root of 9 is 3, right? And that makes sense because what times itself 4 times equals 81? 3, right? But there's a faster way of getting there, okay? The fourth root of 9, so I can take this and split this into the square root of the square root of 9. The square root of 9 is 3, so it's just the square root of 3. Okay, this guy here, so 6 I can break into 2 times 3. So I'm going to split this into a square root and a cube root. And what you want to do is you want to set it up so that whatever your number is, you want to be able to take an actual root of that. So like if I put the square root right next to the 8, I can't take a square root of 8. But if I put the cube root right next to the 8, I can take a cube root of 8. So I'm going to rewrite this as the square root of the cube root of 8. The cube root of 8 is 2, so this is the same as the square root of 2. Okay, next one, the square root of 64. So, I'm sorry, the fourth root of 64. So 4 is 2 times 2, so I can break this into the square root of the square root of 64. Square root of 64 is 8, so that's the square root of 8. And then I can simplify that to 2 root 2. All right, this guy here, so 10 is 2 times 5. So I want to break this either into the square root of the fifth root of 32 or the fifth root of the square root of 32, right? And the way that you decide is that you want whichever root you can actually take to be on the inside. So like there is a fifth root of 32. So I'm going to make this the square root of the fifth root of 32. Fifth root of 32 is 2, so that simplifies to the square root of 2. Right? So these two expressions, both simplified to root 2, that's the same number. Isn't that interesting? I just think it's kind of cool. Okay, this guy down here, same thing, but we're going to have some variables this time. So 9 is 3 times 3. So I can break this into the cube root of the cube root of 27x cubed. Well, the cube root of 27 is 3. Cube root of x cubed is x. So I've got the cube root of 3x. Doesn't simplify any more from there, so we're good to go. All right, this guy in the middle here, so 4 is 2 times 2, so I can break this to the square root of the square root of a squared. Well, the square root of a squared is just a, so this simplifies to the square root of a. Okay, this guy over here, so fourth root, I can break this into the square root of 24a to the sixth. But then we have a problem, right? Because 24 isn't a perfect square. So like I could simplify the 24 into 4 times 6. So I could make this like 2a cubed root 6, but then that's still inside of a radical. And like, is this simpler than that? No, it's not. This is not simplified of that. So this guy right here, this is not what we want. That is not simpler. It's not simplified. Okay? So this guy, we're not going to do this. Okay? So if you can't, right, take the square root or whatever root completely, then it does not simplify. Okay, so it's got to be something that you could actually take a root of. Sometimes maybe like if you flip them, like when we did this guy here, if we'd written it the other way, it would have looked like it didn't work. But when we flipped where the radicals are and made sure the 5 was on the inside, then it worked out. So you just got to kind of watch out for that. All right, and then this is super helpful because when we get down here, when we talked about multiplying, we said that you can only multiply if they have the same index number. These guys don't, but we can use partial roots to kind of cheat and get around it a little bit. So this guy, 6 is 2 times 3, so I'm going to make this the square root of the cube root of 8, which is the square root of 2. And then on the other side, the 9, so I can break this into the square root of the square root of 9, which is the square root of 3. And now I'm left with 2 square roots that have the same index number, so that's just the square root of 6. Okay, so let's do the same thing with this guy. So the 4th root of 8 to the 6th, I can break into the square root of the square root of 8 to the 6th. Well, the square root of 8 to the 6th is a to the 3rd. Okay, that'll simplify more, but I'm going to come back to it in a minute. This guy here, I can break into the square root of the cube root of 8 to the 3rd, because I can take a cube root of 8 to the 3rd. So that's just the square root of a. And then from there, when I multiply those together, I have the square root of a to the 4th, which is just a squared. And that is fully simplified. All right, cool. And then this last one here. So this is the one that I wanted to kind of take a look at. So with this guy here, when we try to use kind of our rules here, this is where I just want to sort of demonstrate to you this whole I thing when it comes to higher powers. So using this partial root rule, I can simplify this to the square root of the square root of negative 81. And then I know that the square root of negative 81 is negative, nope, it's not, I'm sorry. It's 9i, right? So I'm down to the square root of 9i, which simplifies to 3 times the square root of I, right? So when we look at this partial root rule, this kind of lets you see a little bit better why, when we're taking higher powered roots, we don't simplify things with imaginary numbers. Because this is the square root of I. This is the square root of the square root of negative 1, right? So it's not quite the same thing as just a regular old I, okay? So this guy right here, right, you wouldn't simplify it like this, like you wouldn't go through all this trouble to get here, right? But this is just an example, right? This right here is why we don't use I for higher roots, okay? So just kind of a pointing out, if you were wondering about why we're not using the I's, that is why. So that's your partial root rule. Like I said, I kind of like it. I kind of find it fun. It does tend to be a thing that people forget and overlook. So you really want to like train your brain to just make sure you check for that.